So the hypothesis test we just looked at was bill versus percent tip. And we saw that we had a fairly weak correlation or a weak association in our data. And we had a sample correlation of 0.135. Our hypotheses were rho equals 0, rho is not equal to 0. Our p-value was pretty close to 0.1, and we failed to reject at alpha equals 0.05. We're going to now look at the same question with two different variables, or at least changing one of the variables to where now it's still bill amount on our x-axis, but this tip here is tip amount instead of tip percent. So these values are in dollars. We can see from the graph a much stronger association, and that makes sense. If tips were all exactly 20%, then we would see a perfectly linear association. So this is a much stronger association. Since tips are generally between 10 and 20%, we see everything enclosed in between about 10% and 20% slopes here. So we're going to start with the same set of hypotheses, although this time our rho is between a different pair of variables. Rho equals 0, and HA rho is not equal to 0. And we're just going to repeat this test on this particular pair of variables. So we will go to StatKey to generate a randomization distribution. We are still interested in a slope or correlation, so we'll go to the same place in StatKey. And this is another data set from the drop-down menu, so we don't have to upload a file. We'll just go to restaurant tips tip as a function of bill instead of percent tip as a function of bill. And you can see the same scatter plot over here on the right that we were just looking at on our paper. Generate a few thousand samples. We want a two-tail test because we have a two-sided alternative hypothesis, and our sample correlation here is 0.915, so I need to overwrite this endpoint down here, this 0.165 I'm going to click on, and overwrite that with 0.915. And we can see that it changed the scale because that 0.915 was way off my previous graph to where now this sample statistic is way off the end of the tail. And my p-value is 0 to 3 decimal places. So we get our sample statistic is R equals 0.915. My p-value, it's 2 times 0.000, right? Because I have a two-tail test. But that's still 0.000. And we would definitely reject at the 0.05 level. This number, this p-value, is much smaller than 0.05. And so we would reject at the 0.05 level, and we would say that we have overwhelming evidence. We do have statistically significant evidence. If we wanted to describe the strength of the evidence, we would probably call this overwhelming evidence of a linear association between tip amount and bill, and furthermore that association is positive. I wrote that the association is positive as a second sentence just because really our alternative hypothesis is only for a linear association. So this is more of a side observation that we can make from our data. If we were not given a statistical significance level alpha, then instead of statistically significant evidence, we might just say overwhelming evidence. If we were just interested in describing the strength of our evidence and not really able to make a formal statistical decision. We can also indicate at what values, at what commonly used values of alpha, we would still reject the null. And in this case, we would still reject even at alpha equals 0.01, the smallest, very commonly used value of alpha. So we could indicate that as something to back up our statement of overwhelming evidence.